AirTOP allows you to model and simulate the way the flows are managed. In other terms, the measures that can be implemented to regulate the flow of aircraft, as opposed to just letting the traffic flow purely on the aircraft type, performances, limitations, or airspace infrastructure. So we're using the flow management module, essentially to assess and optimize the flow management measures. The AirTOP flow management module supports the plan for the trajectory synchronization and negotiation. So in other terms, not only the geographical position of the aircraft, the coordinates and altitude, but also the point in time. In other terms, for example, when the aircraft is supposed or requested to enter a sector. The airspace plan entry load and occupancy monitoring, essentially constantly monitoring the evolution of the different indicators of the sector and taking decisions based on this. The flow management and demand capacity balancing, DCB, which essentially means not only simulating passively the evolution of the traffic in the sectors, but reacting, so regulating it to meet the requested demand and or level of service. For example, to adopt delay absorption strategies. Time-based or distance-based point-in-space metering to essentially measuring not only the different indicators such as capacity, occupancy, and delay, but also how accurate the planned trajectories are as opposed to the actual flown ones, and how the flow measures impacted the traffic. Like I introduced a few moments ago, we want AirTOP to constantly monitor the demand as opposed to the maximum capacity or requested capacity, being that entry count, occupancy, and so on, to regulate the incoming traffic and find a balance between them. So mimicking the negotiation of DCB measures, the actual demand and capacity balancing. In this animation, there's a sequence of a few aircraft that are taking off from an airport and entering a sector one after the other. Since no specific flows are defined, the only limitation will be based on the aircraft performances. So the departure restrictions and whether, for example, if you have the minimum separation between same seat aircraft and so on, but nothing more than that. So they are free to enter the sectors as they are taking off from the airport. The coloring of the sectors also gives you a visual indication of the occupancy status, so how many aircraft we currently have in the sector. As you see, as soon as an aircraft leaves the sector, the color will change to become blue again when no flights are in the sector. Now, if we look at the bar charts, we can see that the actual entry count, the hourly entry count for that sector was around 10, which is exactly the number of flights that were departing from the airport in an hour. In this case, let's assume that we want to define a maximum hourly entry count of 6 in our model. So essentially, we want to reduce the maximum number of aircraft that will be entering in an hour in our sector. In order to do this, we just need to put a limitation on the flow and set, for instance, a maximum number of 6. You can see that already the second aircraft is not taking off straight away, but will be delayed in order to meet this flow, in order to meet this capacity constraint. You can also notice how the effect of having a reduced demand is going to impact the occupancy of the different sectors. So the colors will never get red or purple, showing a high occupancy, but will be kept between blue and green, allowing you also to easily visualize how these sectors are being operated. So again, in a very simple way, you can define the flow of aircraft coming up from a traffic volume. In this case, is a simple airport, but you can also define a more complex traffic volumes, mimicking either via waypoints, via airspaces, via airports, and going to or coming from, and define your own way of managing these flows. As you can see in the bar chart, in this case, we won't reach the 10 flights movement in an hour, but it will be kept below 6. Coming to the AMAN, some of you might already be familiar with the concept of AMAN, essentially the arrival manager. Well, The A-man can anticipate the demand of touchdown and build a desired and feasible touchdown sequence respecting the minimum runway separation, being that single runway or multiple runways in staggered mode or not. AirTOP supports the modeling of multiple A-man in the same model, so for different airports or for different runways, running together on different runway systems. In this animation, a sequence of aircraft are descending to reach the destination airport. However, because of the limited vectoring areas available, some of them will need to enter the holding stacks to increase the needed separation and keep the arrival sequence when handed over to the airport's controller. However, when activating the A-man, so if we activate the A-man feature in AirTOP and we relaunch the simulation without changing anything else, the strategy will be to absorb the delay while still en route to minimize the holding, yet achieving the requested separation. So starting decelerating the aircraft while en route in order to create the separation beforehand before reaching the initial approach fix to then be handed over properly in the optimal sequence without making use of any holding to the airport's controller.